It's George Sindel, and I'm back again. And I'm here to talk about a couple things. And I'm going to try to clarify a few things so maybe somebody out there will understand. Now, if people make mistakes or you're looking in the wrong direction, you're not going to see what is right. And I'm going to explain this in a simple matter. Okay. What would be more dangerous if, in fact, what I'm saying is true and the meteor showers do impact the Earth? Okay, you have to take into account what's more dangerous. One asteroid impacting the Earth, which we haven't seen, but we have seen meteors impact the Earth. Okay, so what would be more dangerous? Would one asteroid be more dangerous, or would a million meteors in a meteor shower impacting the Earth be more dangerous? You have to think about it and you have to ask yourself. Okay, so far we've only seen meteors hit the Earth. Okay, nobody's seen a gigantic asteroid hit the Earth. Personally, I think the scientists are going in the wrong direction, and it has to do with them not researching the 1833 meteor shower and what happened to Sodom and Gomorrah. Now, why do I come to that conclusion? It's because of other things that are happening. It's because what's happened with Earth's magnetic field and everything. All right, I'm going to explain this the easy way. The mesosphere is made of charged particles. Now, I believe that the charged particles are in the form of like thermal magnetic waves. And this would explain, if it's thermal, why the mesosphere is so cold. If you're producing thermal energy, you have to have a way to cool it. It's no different when you're producing nuclear power. You've got to cool. You have to have a cooling system. Okay. Oops. Now, I believe that the mesosphere is a charged energy field, and it's very possible that thermally charged magnetic waves penetrate into the Earth, into the liquid part of the core, and charge the core. The core is constantly charged that way. You have to think, okay, if the mesosphere is filtering out the harmful rays and it's full of charged particles, okay, well, it's converting them into charged particles, and they have to be going somewhere. Now, why do I think this way? Because there's been disruptions in the magnetic field, and it has to do, what I'm finding out, it has to do with the rocket fuel. The rocket fuel is overloading the mesosphere, and that's why you're having fragments, bits and pieces, or sizable rocks get through. And we're seeing more frequent ones. People are seeing more frequent sightings and everything. But nobody wants to even look in this direction. And it has to do with, because of the way that they think that the Earth was one big ball of magma fire or whatever, and I don't believe that's the case. I think that's totally wrong, and I think Inge Lehman's idea of the core and what she found out is wrong. But it's what's pointing me in this direction, and I believe that solid centerpiece is like a huge, gigantic magnet, and the thermomagnetic waves are drawn to that, but don't go to that centerpiece because the waves don't penetrate the metal core, but they will penetrate the liquid. And if that's the case, then that's what we keep the power generating in the liquid. Sort of like solar energy in a way. But these are just my findings. And I know people are going to go, no. Okay, well, if that's what you want to do, fine. But this is what I'm finding out. And this is what happens when you search for the possibility that whole rocks can get through the mesosphere, you come to these conclusions. Now, that's enough of that, okay? Now I am gonna go to a little something, because like I said, I'm finding this stuff out because I'm searching for it. I'm not sitting behind a desk and I'm not guessing. Okay, now we're gonna go to the TV. What up here on the TV is, that is what the Mars rover drilled on Mars. Okay. Now that we've looked at what the Mars rover drilled on Mars, I'm going to show you my sample from Mars. And I'm going to tell you how I got it. This is my sample. This is the same stuff. This is the same green stuff. Same as in that picture. It'll look green or gray depending on how the light shines on it. It just depends on how the light shines on it. But it is the same exact thing. Okay, now, how did I get that? Okay, well, there's a fascinating thing that people don't know that I do know, because when you find a rock from another planet, they're somewhat different, okay? This is green on the outside. And this is where this green comes from. It comes from the outside. You can scrape it off the rock. Okay, after I scrape the rock, I come up with this color. After the green came off, there was like a bluish color underneath it. Both those colors are on Mars. This is the inside of the rock. And you can see here, by the design on it, is where I just split it open. Okay, now, why the insides look totally, completely different on both sides, but you can follow the patterns and you can look, and there are similarities on both sides. Well, all this stuff in here is what is on Mars. Okay? Okay, all that stuff in there is what is on Mars. Whether people want to believe it or not. The only thing that I have to do now is I've got to start getting me a microscope and start testing some of this stuff. But I'm showing people this stuff up close because 10 years later down the road, when NASA gets their stuff back, this is some of the exact same stuff that you're going to see. But it's already here. And I'm telling people it's already here. But people got to want to take a chance. You got to want to take a chance that actually somebody effed up, okay? And somebody did. And it was done in a big way, and it was probably done by several different people because they're just so sure what they found out, just so sure it was correct. There's no way that it could be incorrect. And man, isn't that perfect? I make errors myself, and I'll admit it. I make errors myself. But you ain't gonna find any of those scientists out there who make errors. Once they find an error, they're that's the way it was or whatever, and now we're gonna change it, and we didn't screw up. And that's the way they play it. But I'm telling you, I have rocks and I have a soil sample from Mars. And the sad thing about it is because experts out there don't want to believe and don't want to listen, they're going to be totally embarrassed when I start coming in with my results. And a soil sample from Mars, I'll be able to look at it underneath the microscope. And I will go out and get a microscope, and I will show the pictures that I take with the microscope. Because see, I know that NASA's done the same thing. They took microscopic pictures of their soil samples. So it'll be pretty weird when I come up with the same stuff that they have, and I didn't even go to Mars. And I didn't spend billions of taxpayers' dollars money to find this stuff. And I'm going to call that good.